slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no.
You know how robots in movies seem almost human? Like they just get what you're saying and respond naturally? Well, that's no longer just science fiction. Meet Helix, the groundbreaking AI system from Figure AI that's giving humanoid robots a serious upgrade. This isn't some clunky machine following preset commands. Helix-powered robots can see, understand, and act on their own. They can pick up objects they've never seen before, collaborate with other robots in real time, and adapt to new situations. No manual programming needed. Sounds crazy, right? Let's break down how Helix is redefining what robots can do. Helix is changing the way humanoid robots move, think, and interact. It's a vision-language-action (VLA) model, which means it doesn't just recognize objects or understand commands, it acts on them in real time. This brings some serious upgrades to what robots can do. One of the biggest improvements is full upper body control. Helix lets robots move their fingers, wrists, arms, torso, and even their head with precision and speed. You can see the robot smoothly tracking its hand movements, adjusting its torso to reach better, and keeping its head focused on what it's doing, all while gripping objects carefully. This level of fine motor control hasn't been seen in humanoid robots before. Another major leap is multi-robot collaboration. Typically, robots either work alone or require a lot of pre-programming to function together. But in the official video, two Helix-powered robots are shown working side by side, storing groceries. They pass items to each other, open drawers, and neatly put things away, all without specific instructions for each object. Instead, they're using the same Helix model, understanding what needs to be done, and figuring it out together in real time. Helix also introduces adaptive object manipulation, which means robots can pick up nearly anything, even if they've never encountered it before. There's a clip where a robot is asked to pick up the desert item. Instead of relying on a pre-programmed list of objects, it scans the area, recognizes that a toy cactus fits the description, and carefully picks it up. This ability to connect language with action is what makes Helix so different from past systems. What makes all of this possible is a single neural network that handles everything: object recognition, movement, and coordination, without needing different models for different tasks. And despite its advanced capabilities, Helix runs on low-power GPUs, which means it doesn't require expensive cloud computing or external processing power. These features make Helix the most advanced AI system powering humanoid robots today. But what really makes it a breakthrough is how it learns and adapts instantly. Before diving into Helix's technical details, let's first recap Figure AI's biggest moves in recent weeks. One of the biggest shifts in Figure AI's strategy has been cutting ties with OpenAI. The company was previously working with OpenAI's models, but Adcock decided to go all in on building their own AI in-house. According to Adcock, the decision came after a major breakthrough in their own AI development, which made relying on external partnerships unnecessary. He explained the move on X, saying, "Figure's AI models are built entirely in-house, making external AI partnerships not just cumbersome, but ultimately irrelevant to our success. This is a big deal because it gives Figure complete control over its technology. No outside dependencies, no licensing restrictions, just a fully independent AI system designed specifically for humanoid robots." Figure AI is making big moves in humanoid robotics, and CEO Brett Adcock just dropped a major update. They've signed their second commercial customer, and it's one of the biggest US companies. This deal is a big one because it opens the door for high-volume robot shipments, which means lower costs and more AI data to improve performance. Adcock believes that with both customers in place, Figure AI is on track to ship 100,000 humanoid robots over the next 4 years. That's a massive step forward for robotics, and it shows just how quickly the company is scaling. The company is now focusing on two key markets: commercial and home robotics. While a lot of humanoid robot companies are targeting industrial automation, Figure AI sees a future where these machines aren't just working in warehouses, but also helping in homes. Their momentum is getting noticed. Futurist and engineer Peter Diamandis last year ranked Figure AI as one of the top 2 companies leading the humanoid robotics race, out of 16 major players. What makes Figure stand out is how fast it's moving. Figure 1 was built and shipped just 31 months after the company launched. But that's not all. At the same time, Figure AI is gearing up for another huge financial milestone. The company is in talks to raise $1.5 billion in a Series C funding round, which would push its valuation to $39.5 billion. Parkway Venture Capital is expected to lead the round, with Align Ventures also co-leading. For a company that was valued at $2.6 billion just last year, that's an insane jump. But it makes sense. Figure AI has some of the biggest names in tech backing them. Previous investors include OpenAI, Nvidia, Microsoft, and even Jeff Bezos, and they already count BMW as a commercial customer. Now, let's return to Helix. Why it's a game changer in AI robotics. One of the biggest hurdles in robotics has always been scalability. Teaching a robot one new skill used to require thousands of demonstrations, hours of manual programming, and tons of fine-tuning. That's why most robots have been stuck doing repetitive tasks in factories. They just couldn't adapt to new situations without massive effort. Helix changes that by applying AI scaling laws to robotic learning. The scaling law in AI says that as models grow and get more training data, their performance improves in a predictable way. This is how large language models like GPT became so powerful. By increasing model size and training data, they started understanding and generating text with much greater accuracy. Helix takes the same approach, but for robots. Instead of needing thousands of real-world demonstrations for every new behavior, it generalizes from existing data and learns instantly through language instructions. This means that instead of spending weeks training a robot for a specific task, you can just tell it what to do, and it figures it out on its own. That's a massive shift from traditional robotic learning, where every action had to be explicitly programmed or learned through countless repetitions. Another major advantage is generalization. Most robotic models struggle when they encounter something slightly different from what they were trained on. If an object is a different shape, a surface is a different texture, or lighting conditions change, they can fail completely. Helix doesn't have that problem. It understands context better, allowing robots to adapt to new environments without retraining. It's also far more efficient. Despite being trained on just 500 hours of high-quality robotic behavior, Helix outperforms older models that needed much larger data sets. That's because, instead of brute force training, it leverages scaling laws to learn more from less data. By applying these principles, Helix ensures that as robots interact with more environments and receive more instructions, they naturally become more capable. This kind of scalability is what makes Helix such a major leap forward in AI robotics. So, what is working behind all this? Helix operates using a dual-system AI, designed to balance deep understanding with ultra-fast execution. This structure allows robots to process information like a human, analyzing the big picture while reacting instantly to changes in the environment. S2 is responsible for scene understanding, language comprehension, and decision-making. It processes visual inputs, interprets natural language commands, and determines high-level goals. Running at 7 to 9 Hz, it functions similarly to how humans think before taking action. S1 takes the high-level goals from S2 and translates them into precise, real-time movements. Running at 200 Hz, it ensures smooth motor execution, adjusting wrist angles, finger positioning, and grip strength on the fly. This is what allows a robot to respond dynamically rather than relying on rigid, preset motions. Together, these systems enable context-aware actions with near-instant reaction speeds. S1 executes the perfect grasping motion, ensuring a secure grip based on the object's shape and weight. This dual-system approach resolves a major limitation in previous AI models: the trade-off between broad generalization and precise control. Many robots can recognize objects but struggle with fine motor execution, while others excel at movement but lack contextual awareness. Helix merges both capabilities into a single, streamlined framework. This breakthrough in AI design allows humanoid robots to function naturally in unpredictable environments, setting the stage for a much bigger shift in Figure AI's strategy. With companies like Tesla, Nvidia, and Meta all racing to dominate humanoid robotics, competition is heating up. But with its rapid progress, high-profile customers, and massive funding, Figure AI is making a serious play to lead the industry. In conclusion, Figure AI is breaking barriers in humanoid robotics and securing major backing to scale even further. With strategic independence, a clear vision, and massive funding on the horizon, it's set to redefine how robots integrate into everyday life. The next few years will be game-changing, and we'll be here to track every step. Subscribe for more updates on the future of AI-powered humanoids.